Welcome to the course Cambridge International O-Level Chemistry. In this course, now I want to discuss about the chapter REDOX. The REDOX chapter, we have total 4 points. The first one, the definition of oxidation and reduction reaction, calculating the state or oxidation state or oxidation number, finding oxidizing agent and reducing agent in a redox reaction, test for oxidizing agent and reducing agent. Let's go for detail. Now I am going to discuss detail about the chapter. The first part, oxidation and reduction. Oxidation is a half reaction here. Electrons lost, electron losing, potassium atom is losing 1 electron. This is the latest definition of oxidation reaction. And hydrogen losing, oxygen gaining, oxidation number increases. Later I'll discuss about what's oxidation number and how to find out. Now reduction. Reduction is a half reaction here, electron gaining. The fluorine atom is gaining 1 electron and making fluoride ion. Hydrogen gaining, oxygen losing, oxidation number decreases. Now I'm going to detail about how to calculate oxidation state. Oxidation number of element in a compound. Roles of oxidation number at free condition oxidation state equal to 0. Like potassium atom at isolated condition 0, iron 0, oxygen 0, chlorine 0. The second formula is oxidation state of any ion equal to the charge of the ion. Like potassium has +1, oxygen has -2. Number 3, in a compound the oxidation state of any element equal to the number of the valency of the element. Like Fe2O3. This is a compound, ionic compound. Here the oxidation state of iron is +3 because valency is +3. Oxygen is -2 because valency is -2. Oxidation state of any compound equal to 0. Like Fe2O3 is a compound. The total oxidation state of a compound equal to 0. Iron has +3 multiplied by 2. Oxygen has -2. It has 3 atoms multiplied by 3. So total we are getting -6 + 6 equal to 0. Now the valencies of the element you have to know to calculate the oxidation state. These are the valency. If you know this one, it will be better, but you can find out from the periodic table. Now we want to give one example how to find out the oxidation state of the element chromium here as potassium dichromate. Potassium dichromate or potassium chromate 6 here, chromium is unknown. But potassium is +1, 2 potassium atoms multiplied by 2, chromium is X multiplied by 2, oxygen -2 multiplied by 7, total 0. Where here we are applying actually two formulas. First one, some of the elements you have to know the oxidation number like potassium and oxygen, but chromium is unknown here. This is variable. We can considering X, so we can find out 2x -12 equal to 0. So for me X is equal to +6. This way we can find out the oxidation state of underlying element here, chromium 3 chloride. The chromium is here X plus -1 oxygen multiplied by 3 equal to 0. So from here calculation, chromium is +3. You can do in your copy and compare with me. Potassium nitrate, here the nitrogen is +5, KMnO4, Mn is here +7, KClO3, Cl is here +5, Na2S2O3, S is here +2, and NaClO, Cl is here +1. You can compare with me after calculating in your copy. Then oxidizing agent and reducing agent. Oxidizing agent. Oxidizing agent is reduced. Oxidizing agent oxidizes another one. Oxidizing agent is oxidant. All non-metals except carbon and hydrogen. Then potassium dichromate, potassium permanganate, and the higher valencies of variable valencies compound like iron 2, iron 3. Iron 3 is the oxidizing agent. Another one, reducing agent. Reducing agent is oxidized. Reducing agent reduces another. Reducing agent is reductant. All metals, also carbon, hydrogen, non-metals, iron 2 oxide, iron 2 sulfate, and smaller valencies compound from the variable valencies. Then potassium iodide. These are oxidizing agent. Now I'm giving you one example here. NO plus CO, N2 plus CO2 in this reaction. This is a redox reaction. First we have to find out oxidizing agent from here and reducing agent. For that we have to find the oxidation state of the underlying element. N is here plus 2, carbon plus 2, nitrogen 0, carbon dioxide 4. From here nitrogen has increased oxidation number, and carbon has increased, nitrogen has decreased. Carbon in the left side plus 2 and the right side plus 4. So this is oxidation. Nitrogen is here plus 2 and the right side 0, reduce. This is reduction reaction. But our target is we have to find out oxidizing agent. Oxidizing agent is here, because it is reduced, and the reducing agent is CO. This is oxidized. Another example I want to discuss, Fe2O3 hematite plus carbon monoxide. This is reducing agent. How it is reducing agent we have to calculate from here. First we have to find out oxidation number, plus 3, plus 2, 0 and the plus 4. Already you know this one. Here carbon is oxidized, plus 2 to plus 4, and this is oxidation, and iron is reduced. This is reduction reaction, plus 3 to 0. Now reducing agent is CO. CO is oxidized and reduces the iron 3 oxide, and iron 3 oxide is oxidizing agent. If you have any problem to find out oxidizing agent and reducing agent in a reaction, you can communicate with us without any hesitation at Catalyst Education. The test of oxidizing agent and reducing agent. Test of oxidizing agent, potassium iodide is reducing agent, already you know. We want to add with the oxidizing agent which we want to test. If the reaction occurs, so reaction happened, so that substance must be oxidizing agent, because oxidizing agent plus reducing agent, reaction occurs. And the test of reducing agent, potassium dichromate is added to the unknown substance. And this reaction, if the color changes, the substance is reducing agent, and because oxidizing agent plus reducing agent, reaction occurred. Potassium dichromate is orange color, and color changes from orange to green. If reaction not happen, that substance will be oxidizing agent. Okay. Now the summary of this chapter: definition of oxidation and reduction, finding oxidation state or oxidation number, finding oxidizing agent and reducing agent, and test for oxidizing agent and reducing agent. If you have any problem, you can communicate with us at Catalyst Education. We have both face-to-face and online education platform. Thank you for watching this video.